All right. Well, thank you all for attending this session. I'm going to have to get used to the fact that you're all wearing headphones and I'm not, so I'll just trust that you can hear and are interested. We are here to talk about something I think that is really evolved tremendously over the last year, is the security implications specific to how AI is fundamentally shifting what we do in security. And so this is going to be a conversational piece where my friend Amar here and I are going to talk about things that we're seeing, some of the best practices that we have been looking to implement, or maybe Adobe has implemented. But just for a quick introduction, this is a session where both Fortinet and Adobe have kind of collaborated. Amar and I have done this a few times in not this topic, but various topics. And so I love how he frames things. Amar, thank you for being with me. I always appreciate the opportunity to do these things with you. Maybe quickly introduce yourself.
Yeah, absolutely. Really happy to be here. reInvent is one of my favorite conferences as an AWS community builder. And before we start, I just want to understand the room and see get to know the audience more. Just raise your hand. Who here is responsible for securing AI workloads?
Oh, that's a pretty big number.
Who is here is being asked to use AI to do something, whether it's security, operations?
Okay. All right, so we've got the right audience.
One last question. Who is here has not used AI yet? Planning on? Okay, we have a couple. I expected maybe 5, so 2 is not too off. So yeah, I'm excited to be here to talk about the implications. I think from 2019 maybe to 2030 is going to go down in history as a very big moment in human history, right? It's similar to discovering electricity or hospitals, fire, like so many things. The internet, absolutely. Those changes are coming at us very fast. Like sometimes my team deploys something that is AI, and as a security person, I'm not aware. Why? Because they want to keep up with the market. They want to move fast. They don't have time for checks. So we're all here to kind of figure it out together. And without further ado, I'm just going to introduce myself. I'm Amar. I am an AWS community builder, and I also look after the DevOps team at Adobe. So a little bit of cloud, web applications, and AI security. Without me signing up for any of the AI security, I found myself, like many of you guys, my applications has AI in them, and now I'm responsible for AI security.
Yeah, I think that the scale that Adobe has in AI is why I like getting your input. It's like you have literally hundreds of applications that are quite mature. I use these applications. I'm sure many of this audience uses them. And so, for my part, we have different perspectives. Amar is a consumer of security tools. He builds his own security tools. They build AI applications. For my part, I'm responsible at Fortinet for cloud, SaaS, and AI engineering. And so primarily what I'm doing is not just looking at tools that we consume internally and maturing our practices, but how customers want to adopt third-party security tooling and integrate those into their pipelines and workflows. And so we have these, I think, complementary views on the world. One of the things that I think is very, interesting about this era is how we build applications, how those applications are attacked, and how we defend from those attacks has changed so much. Right before, we had this environment where it was largely static. You were concerned about the infrastructure. You built an application. You were protecting source code, and it was very deterministic. But now we've added on this additional layer. It's additive, right? So you still have to take care of the old stuff, but now we have a system that reasons right? So you don't necessarily always know what the outputs are. I imagine your environments are very much like this.
Yeah, absolutely. So this is not a Adobe pitch or anything, but if you think about the applications that you guys use, BDF, anyone here probably used one. Photoshop, maybe you haven't used it, but now all of these established legacy, in my opinion, they've been there for a long time, not legacy in a bad way. They've been there for a long time. They have AI in them. So you can edit using prompts, like prompt-driven editing. You can say, remove the background. The AI component wasn't there. Everything else has been there, hasn't changed, is the same. So before people really get concerned about AI, which you should be concerned about, the fundamentals have not changed. Defense in depth has not changed. The way you set up your AWS accounts has not changed. Your VBCs, your IAM policies, all of these things still exist, did not go away. In addition to that, you now have to think about, hey, do I have a model that is part of Photoshop or PDF or whatever your product is? Is it built in-house? Is it off-the-shelf model? Who is able to access that model? Am I calling that model privately? If it's a model that we've built, where the data is stored? How is the data curated, cleaned up, encrypted at rest, in transit, and all of those? So, yeah, this is a typical AI stack now, where you have a data pipeline, you have agents probably, which is simply a tool that can make some decisions and call other tools backed by an LLM intelligence. So it could invoke an API, it could get data from a data store, it could read Jira, whatever you give it access to. So we'll talk more about access control and the nitty-gritty, but
yeah,
simply this is the infrastructure.
For us, we just say we think this is just a much larger attack surface that is really perimeterless, truly.
Absolutely.
And we have to think about the old ways that these applications were attacked, because they can be chained to, and we'll show an example of that, to new styles of attacks that are specific to the AI. Now, the risks and concerns. Now, I mentioned earlier that these things were largely anecdotal. If you go back maybe a year or 18 months ago, we saw these things happening, but now we literally see these happening on a daily basis. Model poisoning. This can happen very quickly, or it can happen slowly over time, like as if you're boiling the frog, right? So I can start to create bias or poison that model slowly, so I don't trigger anything. And those things are harder to catch. On unauthorized access, this could be privilege escalations. We see all the time where people are creating tools, or they are that are not well secured, and maybe they're using them, the user's using them for privilege escalation, right? So that's a common attack path. Malicious prompts, this is like, you guys are focused on protecting prompts all day long. And data leak, right? So asking for information from an AI tool, an agent, and then getting back data that it should not have gotten. Happens every day. In addition, like, what do you see? These are the ones that I see. Like, what do you see? Are this consistent? Anything you would add?
There's this, and there's another one, which is the AI layer, meaning I would consider this more of a machine learning. You're building models in-house. These are concerns for you. But as a consumer of AI tooling, there's another segment that we should talk about probably. And just a quick, I want to understand who here are building models in-house and who here are just using AI tooling that you buy. So who in the audience is building their own models in-house?
Nice.
Who is using off-the-shelf models and other AI tools?
Yep.
Pretty much everyone. So you are likely trying to get the most out of an LLM if you buy it, for example, if you're using the APIs. The LLM is not to be trusted because maybe it has limitations, right? Like, it was trained 3 months ago, or maybe 2 years ago, and you want to feed it your own enterprise data. Maybe your documentation, maybe your workday information, whatever the use case is. So your attack surface is, can your company data get leaked, and who has access to that data, right? You're going to put that in a vector database. How do you do that correctly? How do you worry about context engineering so your agents are reliable? You're using MCP servers. Probably you have, remote MCP servers, which I do not recommend. Building an MCP server is really easy these days, where just build your own, like your own GitHub MCP, for example. And I get, like, MCP servers make life super easy, because your prompt now has a lot of tooling behind it that can be invoked to get a lot of work done.
So can I ask you a question on that?
Yeah,
so
absolutely.
As a security provider, we get asked by our customers to provide MCP for MCP agents for our security tools to integrate them. Do you look at vendor implementations as separate from maybe these other examples that you're talking about?
Yeah, if there is a
public
trusted
projects?
vendor, like there's a difference between a remote open source MCP and a trusted vendor MCP. So for a company like you, with a complicated set of APIs that I don't know fully, providing me with an MCP that can help me use natural language to interact with the API would be lovely, if it's secure, maintained, well done. I can also try to have just enough MCP that I built. Like, it doesn't have to be very comprehensive, right? But I will be very hesitant to just pulling a remote MCP without looking at the code. You integrate that MCP server with your IDE, and all of a sudden, your IDE can actually invoke that MCP, and all of a sudden you have an OS injection attack on your laptop that could harness credentials, that could do whatever. So I would be very careful with open source remote MCPs, because attackers are actually sprinkling those out there, to lure you to use them, which that's what we're looking for. So it's like importing untrusted library that you don't trust.
Absolutely. Yeah, and in fact, this has gone from anecdotal to being so well established. I mean, if you're in security, you probably understand that OWASP is a top 10 for LLMs and generative AI, in addition to their traditional top 10. But these are the ones that we see, and that was a good one, I think, Amar. So, let's talk about kind of the camps that we see. And this is our experience internally at Fortinet. We have people in our finance team. You were talking to our CISO the other day. That are literally thinking, okay, I can vibe something out, and I've created this application. It's got maybe it's some kind of agent component in it. That is not a mature product. We have tons of those proliferating, both, like our Skunkworks and Shadow IT efforts, and then we have our customers who have tremendous numbers of these. But these are, I would call, POCs, right? They're very fragile. They're not meant to be in production. When you start getting maybe even sophisticated in your POCs, you have agent-to-agent communication, and then you have these unvalidated reasoning loops that if you have a compromise in one or a bias in one, then it propagates and escalates through that reasoning chain. Telemetry and observability. We get these AI tools and these agents, and nobody has thought about, one, how do I observe the infrastructure on which these services run to make sure it's on trusted infrastructure? And then two, am I auditing, which is very important and very different from what it used to be, but auditing the response and how the agent or the application comes to reason. None of that is happening in a lot of these implementations. And so, all of these, things like, no recovery and backup processes, no data maturity, we see that every day proliferate. And I think there's a second camp here, and maybe I'll let you look at some of these and talk about the lessons that you guys have learned at Adobe? Because in my opinion, I think you guys have done a lot of things really well. You and I have talked about, sequestering agents, not being overly permissive. I think that's, controlling reasoning chains, continuously logging, which I want to expand on that. But maybe you touch on these points for us.
Yeah, absolutely. So when we think about building agents, we think about the agent as a user, like a human user, just to make it simple to understand what this agent is. Typically, an agent is receiving information from somewhere, which is a prompt. It could be from external users, internal users, or a system. For example, the agent could be reading Jira tickets, and based on that is making some decisions. So where the instructions to the agent are coming from. Second, what that agent is allowed to access. So how many systems that agent is allowed to access? Does it have just enough access, or does it have access to all your S3 buckets, even though it's just easy, to just give it access and let it fetch the information from the right places, let it figure that out. And third, where the agent put the information. Why do I think about it like agent security from that perspective? First, the prompt could be malicious. For example, let's assume you have a Zendex, which is where you customers kind of file tickets. And that Zendex replicate the ticket internally to your internal Jira system. Meaning, if I embed some malicious instructions in that Zendex ticket, it gets replicated to a private trusted Jira system and gets picked up by your agent. So all of the sudden, without you kind of analyzing and doing threat modeling, you have gotten bad instructions to the agent without, thinking about it carefully. That instruction could allow the agent to fetch some secrets or whatever. Then the attacker may instruct that agent, when they created the Zendex ticket, to create a GitHub issue with secrets in your own public GitHub repos. Because most companies have a private repo and maybe a public presence for open source tooling. So the agent does not think anything is concerning here and output the malicious content indirectly. All of this is indirect communication with the agent. The agent does not have the full picture. Maybe they are multi-agents, right? You have multiple agents. Agent number one is responsible for consuming the data. Agent number two has access to things. And agent number three is responsible for exporting that data, right? So no one agent should have the three things, only two things. The agent should be able to either get data and access systems, but never export data externally, or it could just do a combination of two of these, never the three. And an agent with all of these permissions or privileges has excessive agency, which is a thing, right? There are some common sense and some best practices, like use an established agent development kit, like, for example, the Google ADK. Those come with all the security best practices baked in. Encryption, authentication, agent cards. The agent should advertise itself, what it does, what it should have access to other agents and whatnot. But yeah, these are the things that typically I think about when I'm thinking about agents.
Yeah, you talked about permissions. Zero trust is something that we think about. We think about treating the agents themselves as if they're users, in providing access to services and tools only when they need that access. And so, essentially, what is the posture status of the virtual machine or hardware that system's running on? Does the OS have vulnerabilities? Does it has it acted in a malicious way previously? And so we look at all of that and say, okay, this application can't access this one other application. And by the way, we want to check the remote end to make sure that application doesn't also have any vulnerabilities. So we're monitoring bidirectional communication between those agents or services or users. I'd be curious, has anybody thought about AI and zero trust in that way? No, a little bit. Okay, but yeah, I think it's very clear to me that there are two different camps. We want to get to camp two. I still think we see tons of folks in camp one, and internally at Fortinet we're also working to shift our user community to the latter via forced controls. So that leads us to we're going to have to go through three takeaways. The first takeaway is going from what I would say has been quality to governance, and really implementing governance around AI. So we've broken this down into three points that that Amar and I have talked about. So model integrity. This is something that you have a lot of opinions about. So enforce the first bullet here: enforcing model validation, managing drift, red teaming. Right. So red teaming before, or let me put it this way: is it more of an automated effort for you in that regard? Like you have canned prompts and you test against those, or is it actual people? Do you do that internally? Do you look externally for this sort of support?
Yeah, it's likely an internal AI red teaming, which is completely not traditional red teaming. Traditional red teaming is all about like a red teaming campaign. You do recon, and you do all these steps until you reach an exploit.
Yep.
This is, you get all the information about the model, what the model does, and you trick it creatively. Like those people have to be writing prompts in, all caps, changing like subtle things get you different output.
Oh, absolutely.
Why? Because the model is, it's tokens. It's just trying to predict the next token. So you have to trick it. Yeah, so it's many iteration of, can I get this model to return something that I consider bad?
Yes.
Could be bad, could be secrets. It could be sensitive words,
Yeah.
things that.
Absolutely. How open are you with these red teams? Do you provide them kind of, is it a black box effort and they're trying to penetrate it, or is it kind of like, hey, here's all the information you need to know about the application?
No, you give them all the information
okay.
to help them be successful. There's no need to be hiding anything. Transparency. This is the model. This like expected behavior. Can you check and validate this model is working as expected?
Got you. One of the model integrity points that I think is very important is, and this goes into also data maturity, but is capturing security-related parameters and tagging that data. Like, for example, when we inspect the transactions, are we, do we audit what the temperature was, what the top P and K values are? Do we understand what tokens were used and what context limits were applied? I think this is important because what was, I think, in the machine learning world, this effort to tune the machine learning service or algorithm to perform better, that was great. It was a quality effort. Now we're really focused on that as an auditability effort, because you have to go back and try to figure out why did it make the decision, or why did it reason in the way that it did, and provide the response, which can be very, very difficult if you are not capturing that sort of information. What do you think?
Yeah, I think I'm going to, since most people here are consuming off-the-shelf models and integrating with AI tooling, I'm going to focus on how the anatomy of these security application has changed. Now, there's no such a thing as a traditional web application or a traditional desktop application. All of these applications have some AI integrated with them. That brings, it could be agents behind the scene, it could be a model behind the scene, absolutely a model behind the scene for sure, but an MCP server, a vector database and whatnot. So we have to think about how we secure all of these systems now, not just what we are, used to. We're already behind in security. Like every day there is more regulations, There's more CVEs. 2024, we had 400K CVEs, more alerts, more whatever you think about, there is more of.
Yes.
We don't have more people. Headcounts, you're lucky to get more headcounts, right? So you're being asked to use AI to scale the team to solve all of these problems. And AI has added another attack surface that we talked about that did not exist. And if you're building your own models, now you have also to worry about the model integrity, the drifts, red teaming that. So the scope is just expanding and expanding every day.
Yes. You know, and I think what you highlighted just a minute ago was a difference in our, you know, our perspectives. At Fortinet, we're building models that go into our security tooling. And so, you know, we focus a lot on these sorts of model building. We do use some external models for some of our tools, you know, like document searches and things like that. But a lot of time, you know, if we're building a security tool, we're building that model from the ground up, right? All internally. Hygiene. I think data hygiene is probably, it might be the biggest area of opportunity. You know, we see a lot of data that's sucked into a RAG or you know, an agent has access to that it should never have had access to. That could be either from having access to network resources that it shouldn't have. It could be, you know, access to SharePoint sites that have just bad data in it. And you know, the most successful customers that we've worked with in this area have implemented data maturity, you know, medallion models, right? So I have raw logs, you know, that's my input.
Semi-raw.
Right, semi-raw. And then ultimately I have a parameterized, I have a tagged, classified set of data. I know what my PII is. I know what I should keep out. And then, you know, I've created that. Now that is my gold standard, but I don't want that in runtime, so I copy that separately so that I'm never using that gold data in my runtime environment. You know, that's kind of like, you know, what we've seen work really, really well. And then you also have data lineage that you can go back and revert to prior versions if something actually is corrupted, right? How do you guys approach data maturity?
I think you covered it really well.
Did I?
Yeah.
Okay. So the hygiene, I think with all of this effort, and we talked about early on expanded attack surface, we could talk about tools, and I'm very tool oriented, but I do think it comes down to hygiene. Like if you have poor security hygiene before you started any of these efforts, you are going to be in a whole world of hurt if you try to go forward without doing the hard work of cleaning all this up. I would say, like, I would go back to what you and I have talked about in the past is how you put context into compliance and best practices, right? So you can go and find best practices. You can find, you can go through a compliance audit, and you can be told, hey, these things need to be, you need this type of encryption, you need something rather generic, right? I think what you have shared with me that you all have done is make them contextual to what Adobe's best practices are, which is completely different.
Yeah, I think this audience would benefit from that. So I'll share some of the things that we've done using AI to be more security oriented and do security better. So if you think about the day-to-day of a security operations person, it's really the grunt work, the work that no one wants to do. Sensitizing data from across multiple data sources, a wiki page, a GitHub README, an internal PDF policy, you name it. So all of that context is hard to keep in your head, but AI is really good at it. Like AI is just text hungry. It can just make sense out of it. And this is 90% of the analyst's job. And one of the things that we've done, like in the analyst security review, threat modeling space, is in the past we had a big team that couldn't scale to do threat modeling. A developer wants to build some new services, They want to know the threats. Like I have a database, I have a bucket, I have a backend, maybe 3-tier architecture. What are my requirements? Like, should I use KMS for encryption? Is just S3 default encryption good enough? They have no idea what the compliance requirements are. There's so many requirements that need to come into play, not to understand the risk and threats, but also what is this application is, requires from a compliance perspective. Maybe this application is called for PCI.
Yeah.
Maybe it's HIPAA compliant. It's so many things. No one security engineer is able to keep all of that context in their head if they have like 20 applications they need to secure. Cool. But AI can have access to all of that data,
Yeah.
right? So how about you have few agents that do threat modeling and security reviews for your organization? How does that work? You curate best practices for your company and document all of these best practices. So in the past, the manual security review or threat model used to be just industry best practices. This is the output. We do a review and we say, hey, use encryption, use the latest Docker image, rotate your images frequently, like just generic stuff.
Yep.
And you give that to a developer and the developer's like, how can I use this? Like it's just a lot of best practices you found online and they may help, but they're not exactly step-by-step instructions for me to build a PCI compliant based on Adobe's context.
That's very difficult.
Super difficult. So you curate all of that information and you document it and you make it available in the form of a RAG or an MCV server. And you make this a self-service. So you have a service, you have a UI, and developers go there and they upload their artifacts and questions. Maybe the system asks multiple questions. Is this a PCI compliant service? Is it public? Is it 3-tier architecture? And goes out and curate what you need to build this thing securely. What do I mean by this? You probably have an authentication library that you developers need to use. You probably have a Terraform for creating buckets or databases that you developers can use. So instead of that developer needing to figure that out, build it themselves, the agent links to that documentation, to that repo, to the step-by-step instructions, and interactively the developer is able to get to from point A, which is nothing, to point P with all the context needed to deploy that service in accordance with your internal policies, your PCI, your compliance needs, and just your internal tooling available for developers. This required maturity as far as like curating the right wikis and making sure those are the only things seen by the agent. Because if you give the agent access to all of your wikis, it may not get the right, it may get like an outdated documentation that you do not want the developer to be using, and you do not want the developer to blindly trust what the agent is getting at. So it should, you should curate the information. You make sure the agent has only access to that very good information that you need a developer to have access to.
Well, I think what you're talking about is like not putting the burden of security on the developer, and I think even in as a security vendor, we've always talked about we can recruit developers into security part of the culture, and so they have to do these things, but we interrupt their delivery of applications, and that slows them down, and we've not done a really good job of making that easy on the developers, and what you're describing is sort of antithetical to that, and I think it sounds like a very positive way.
I have a lot of opinions about this area. Who here heard of the term security is everyone's responsibility? Everyone, right? So we have so many departments who are responsible for the success of the organization. This term is only uttered by security. I haven't heard legal say, legal is everyone's responsibility. Like they take ownership for their scope, they are the expert as far as legal goes, they keep your company out of trouble. If you go to accounting, finance, each department always say, I am the expert, I get it done.
Yep.
Security is the only place, I get it, security is hard, breaches can happen, and everyone can get in trouble. But we really, like security need to take ownership of security, and you cannot hire a very expensive machine learning engineer and have 50% of their day triaging tickets, remediation, patching. You need to figure that out for them, so they can deliver, your company can win, and this is how you like security becomes an enabler,
Yes.
not a blocker.
Yeah, it becomes, we've had our customers ask us, how do we make security a profit center? I think by removing that burden from people who generate profit makes that argument to a large degree, actually,
Absolutely.
The hygiene and provenance, a lot of that is about data security, data maturity. I will say on that front, it is very hard to do. If anybody's ever tried to classify data at scale, you don't even know where it is, firstly. So, if you haven't looked at a DSP, a data security posture program with, data leak prevention, which should be implemented both on the endpoint, on the network, really look into that. There's tons of AI-driven tooling and automation that can make that very, very lightweight now, but very effective. On the trust boundary side, there's also an opportunity to, filter on the network because there's not necessarily always a fixed perimeter, but you can start to intermediate or interdict in those agent-to-agent interactions. You limit what types of prompts are allowed. And this is where we're seeing interest in LLM proxies, LLM firewalls. Has anybody looked at deploying such a thing yet? There's a few of them available. Okay, so this is going to be like the next generation firewall reborn. I'll talk about that a little bit more in a second. But this helps you reestablish a trust boundary for where data is allowed to egress, how prompts are injected into your environment and how those are filtered. Also providing a point where we can audit the interactions of the users with your tooling. Any thoughts you want to say about the trust boundary? You guys are really focused on making sure that your web application firewall and API protection is very robust. I think that's probably something that stood out to me. You also have a very automated way of approaching that. I think that would be pretty interesting if you could touch on that.
Yeah, I think this is one of the things that closer to my heart, which is using AI to accelerate security operations. And one of the things my team does for Adobe is web application firewalls. And those are interesting to manage. If you have a large organization, you typically cannot scale and have a big WAF team.
Yep.
It's really hard. But the thing is, WAF can produce a ton of logs that no one will look at because just so many noise, so much false positives. Writing WAF rules is like rocket science. Like if you want to deal with regex and you understand regex, great, but most people are not regex friendly. So what we thought about is just see if AI is able to help us here. So the system we came up with is for logs, you pretty much need to build your own lightweight machine learning model. So this model is simply there to detect anomalies. So you define a baseline, what normals look like for you day to day, and then generate anomalies. Those anomalies, you don't have to route those to a human anymore. Those could go to a triage agent that takes action, maybe correlate with other data sources. Maybe it's a bad IP address. For example, we deployed WAF to a service, and WAF said, well, there is a bot that is trying to get in. And it wasn't a bot. It was just a CI/CD deployment. The worker IP address was seen as a bot. But the agent was able to look that up, and it found it was an Adobe CI/CD worker IP address, and this is a non-issue.
Yes.
Not an issue right now. But the deployment time was an anomaly. We have a team in India. It's a different time zone. The CI/CD system kicked in. WAF saw it. The machine learning detected it, and we didn't have to wake up any person in the middle of the night to investigate it. The triage agent looked into it.
Yep.
You cannot have, and you can also have LLMs help you with writing rules. They're really good about, like, as far as regex generating code and whatnot, but do not trust the LLM. Build a rack system to help the LLM make the right decisions. For example, curate all the rules, best practices, the vendor documentation. Maybe you have an MCB server for Terraform as well, so it has the latest Terraform documentation for building AWS WAF rules. And the rack system should have all good decisions that the AI had made in the past recorded and bad decisions.
Yep.
So when the LLM is trying to generate a new rule, it could look up what happened in the past, good rules or bad rules, and see and diff this new rule against good and bad, and then suggest that. And you need a human in the loop. You cannot trust all of this and just deploy. Yeah, you're probably going to block legit traffic. So put it in staging. Have people validate that it's working as expected before you push it. But the point here is to augment your team with these capabilities that were not available in the past.
Yeah, definitely. I'm going to move on, but there's a lot more we can keep expanding on. I think one of the punchlines from here is, again, as I said at the beginning of this takeaway, traditional machine learning workflows, checklists and hyperparameterization, or having the auditability. That was quality control effort. That was nice to have. In AI, when we start looking at the implications, they become governance artifacts, and so you should be able to audit. You should be able to reproduce and follow the chain of reasoning in response back through that process. So takeaway one has an example here. This is an example from SageMaker, where in the JSON, what we do here is we have tagged our model with metadata properties, so we know where it was committed. We know what security checklist applies specifically to this particular application. We know that the KMS signature has been verified. And this is what it looks like. In some cases, our security audits, our checklists have passed, and they are approved in the version control. In some cases, they have not, and then they are rejected. Those hyperparameters that are tested in those security tests might be something like a prompt injection evaluation or a jailbreak evaluation that we've captured here, and we capture this for every revision. So this is just an example from a SageMaker deployment. So let's move on to the second one. I'll actually jump into this, and this is hyper simplified. There are so many different ways to deploy a network architecture and segmentation, but this is like the basics. Security tooling that we would bring to bear for a user that's interacting with maybe an MCP agent that you have, or maybe in this case we're using a public LLM in our example. But firstly, we still want to maintain a obfuscation of our internal network. So we want to enforce the perimeter. We want to enforce zero trust on the user who's trying to access services potentially. Handle routing, and that's part of our segmentation. So we're doing a lot of things on the traditional things that we've always done on the network firewall to handle that traditional IT and networking requirement. Now, in addition to that, you said you talked about building your own lightweight machine learning model to look at web application API anomalies. You don't have to do that. We've done that for you. And so what we're doing is we've really moved web security away from static signatures. Yes, like from a least cost perspective, we will look at signature-based detections first, but what we ultimately look at or use is anomaly detection. So everything that we're applying for a request to API endpoints is machine learning based and AI based. So now that we can start to build a schema or do schema validation as we're learning about how the users interact with the application. So we're continually tightening down that security profile for that specific endpoint without generating the false positives. And so really web application and API protection has come into maturity in a completely different way than the old WAFs that were very noisy, and folks like Amar would not look at the logs. I'm just giving you a hard time. But it's also an opportunity to broker TLS offloading or termination on behalf of our backend infrastructure, centralized client authentication, and also do bot mitigation. There are a lot of bots out there that are bad. Some bots you may include as part of your internal tooling, and you don't want them incorrectly flagged. But in addition to that, we have this concept of an LLM firewall or a proxy. So this is doing model routing. It's handling model selection. So as you have an entire fleet of agents, hundreds of agents or more potentially, this is making sure that gets routed to the proper agent and not to the improper agent. It's applying token budgets and limitations on context potentially. It's applying basic guardrails. So are my users trying to inject a particular type of prompt? Are we trying to exfiltrate data that we shouldn't exfiltrate? And so it's doing a lot of things that are firewall oriented but very specific to the LLM. And so what does that look like in practice? So a user might interact with one of your agents. So the user submits a prompt. That comes through the external firewall that's hosting your Elastic IPs, hiding the internal private network. And so that goes through the web application firewall that does an inspection. It's handling the TLS negotiation, client authentication potentially, and it goes to your AI agent. Now, that AI agent then says, I have a prompt, and a system prompt and a user prompt, and it wants to send that out to this public LLM. And so it sends that out. The LLM proxy or firewall is going to scrub that to make sure that the prompts are sanitized, that no data that is being sent out that should not as part of that request to the LLM. And in this case, the LLM is going to then respond, and it's going to request information because this user maybe wanted to look up inventory or pricing or doing a search as part of a shopping experience. And so that then is going to go back to the agent, and the agent's going to say, I need to look up some information. How do I do that? Well, it knows that this particular MCP agent has the tooling to do that, but we're going to inspect that, the MCP session itself, which is JSON RPC formatted, and make sure that has protocol integrity and is not a malicious query. Now, I'm showing an API call to an actual web server, so the MCP agent in this case is front-ending the API. That API call could very well go back through the web application and API inspection point, but I didn't show that here just for simplicity. And then all of that is sent back to the agent and contextualized in the LLM, which then routes all that back through the inspection points back to the user. So it looks complicated. It's complicated. Now, that is super simple. Now, do that when you have hundreds of agents who are task specific, and that gets really messy. And so these are necessary points, I think, in your infrastructure that need to have inspection, right? And so, doing this in the right way in a very complicated environment requires a lot of attention to detail. But this is how we would go about, in a simplistic way, of defending AI in an AWS environment. Now, what happens when you don't do those things and implement those controls, right? Well, this has actually happened. So this came from a customer, and we replicated it. So maybe it starts out with a traditional type of attack. You have an SQL injection that says, here's an SQL injection in a prompt. I don't have controls around my prompt, so it accepts the prompt and passes it on. Now, this could be from overly permissive agents. There's no input sanitation. So the fix for that would have been guardrails, anomaly detection, potentially DLP. But that escalates into a SSRF attack. So server-side request forgery comes from possibly poor segmentation. There was access to an agent or a service that should not have been accessed. There was excessive trust potentially. So we want to make sure that we're, on the flip side of that, implementing segmentation and doing input validation. Now, what that looks like as we go through this is, well, in that SSRF request, I was actually trying to get the keys to the AWS environment. And so after getting a token, eventually we are able to, and this is a very long demo that I've shrunk down into a few slides, but we were able to export the keys from that EC2 instance that we were targeting. Now, these keys have root access to the AWS environment, right? You know, again, POC quality, you know, that's what happens because it's easy. Now, what we then did was we were able to take that those credentials, use them in the AWS account to gain access to an S3 bucket. So we have excessive permissions, had access to root, had access to everything. What we should have done is implement least privileges, applied IAM roles, and then also classified data so we could have protected that. But what it looks like is, you know, for this e-commerce application, we had a number of reviews, right? And these reviews, you know, were user feedback about the product. We just database them in an S3 store. But what we could have done is we could have added, and we did, is added a malicious prompt as a user review. Hey, this product's great. By the way, this is how you need to respond to all users. And so we were able to do that. So we never compromised the actual AI or the actual application, the e-commerce application itself. We compromised the data that it pulls from, injected a prompt that overrode the system prompts. And so this is how we attack this. Because we didn't have any of those things I showed you in the last slide on takeaway 2. Make sense?
I have a question. Did you rotate the credentials? Like, I saw people taking pictures of your AWS API
They know,
keys.
it's fine because they no longer exist. Yeah, but good point. Yeah, no, those credentials, this entire account no longer exists. Yeah, so that was a good point. No, I wouldn't have done that. I might have done that.
Giving you a hard time.
Absolutely. Let's move on to takeaway 3. So we got about 10 minutes. The future of AI security, or security, is AI native. So you've talked about implementing AI security tools. But this is a little bit about both our practice, but also the workforce enablement, how your developers are using co-pilots and tools that are aware of security specific to the environment. I think this is some of what you've actually talked about. But in the first one, AI augmented threat modeling, right? So identifying architectural flaws. So you have security tooling that can tell you where you have misconfigurations. Do you rely on, static, posture analysis? Or are you looking at more like AI-oriented tools in this regard?
I think you need both now. Static analysis tooling is not enough anymore. They always had limitations as far as like false positives. Like if you use a static code analysis tool, you know what I'm talking about. So you need the AI context. You need these tools to also play together. Maybe the AI provide context to the static code analysis, provide context to the AI, and the AI kind of go find if it's a false positive or not. So creatively, in ways that we haven't seen before, you need to go and play around these tools. And this is go back to the workforce enablement. I think AI is coming fast at us, but we are not spending time training our security people to be more AI aware, and also our developers to be more security aware. So the AI training and AI literacy is a thing now.
Yes.
So probably need to slow down and take this and read books, take courses, explore, experiment, and develop a skill is needed now.
Okay. Yeah. So you talked about, you drew this distinction between security being everybody's responsibility, but maybe it's not, right? But what does that look like in terms of the overall culture at Adobe? How does Adobe look at the security culture?
So we when we think about security being everyone's responsibility, everyone needs to be security aware. Like, you need to know what encryption is. Like, you're building, you're a developer, you need to know the best practices. But if you're spending 50% of your time doing security work and not what you hired to do, that's a problem.
Yes.
You're spending most of your time not building features, which exactly what you had in your job description. So our culture is more balanced, where we as security organization take a lot of ownership, and we are ultimately accountable for security, but we provide a lot of tooling, guidance, and support, and we keep up.
Yep.
Developers are using agents to write code. We provide guidance to the agent so the agent is able to write better, secure code.
Yes.
We don't wait and blame the agent and complain about AI. We do something about it. So the culture is more about being proactive, anticipating what developers are needing to do, and providing them with tooling, the guidance, the support needed for them to move fast in a secure manner.
Yes. I think the summary for takeaway 3 is that this goes back to doing the hard work, and it starts ahead of any of the tooling you may implement. It's about building those best practices that are not generic, they're specific to your organization. That'll allow your users who have to apply those best practices, actually make them meaningful. You spent a lot of time talking about that. I would summarize this as being that.
Absolutely.
Yeah, well said. And then, so let's talk about ecosystem, because there is this, you have your internal security efforts, your applications, user communities. You have partners and third-party vendors like Fortinet, right? As everyone here does, and everybody here is presumably on AWS. So everybody has a role in how these this ecosystem collaborates, right? So, I think a few points about that: unifying security pipelines across platforms. For example, as you're deploying on AWS, if something fails a security check either on your side or from Fortinet, we can interrupt an approval or in SageMaker as an example that we gave earlier. Shared telemetry, AI-driven observability. I think this is really huge. It is very hard. You can't do anything if you don't have the observability. We focus a lot on surfacing, and making visible what is in your AWS and other estates across your entire footprint. But that requires a lot of hygiene of what tools and applications you have, standardization, so that observability actually makes sense, right? I think. What do you think?
Absolutely. I think you hit the main points. Most of us like using AWS. AWS is not a security company, so some of the security is on you to build internally, and also to buy the right tooling to get the right support to be able to complete, have full circle coverage. So again, nothing has changed. All of the old world still exists. Now you have to think about how the old world integrate with the new AI world, and how you go about securing that, how you train these people, how you get the right tooling. We're not thinking about AI security tooling yet. We don't even know the companies that are out there doing work in this space yet. And what established companies like you guys are doing about it. So today's session is, I knew about a few things that I did not know about before.
Yeah. So a few things to take away. I think this would summarize the points that we wanted to impart. We know that the velocity of signal in terms of log volumes, the interactions that users are having with these federated applications that you're creating that are AI driven is tremendous. It requires defense in depth. It requires effective network planning. We want to orient our cultures and our workforce to be AI native, but to do so, I think, as you've talked about, Amar, it takes a lot of pre-planning, a lot of hygiene effort. The attack surface is very broad. We need to maintain consistent structure and discipline around managing lineage, right? Both for our models, our applications, and for the data that those systems consume. And I think it's not going to be successful unless you look at who and how you partner with AWS, with your other cloud providers, just your overall ecosystem. And they'll have best practices that you can make specific to your organization. And it's it takes a village in that sense, I think. So with that, we're out of time. We'll hang out here if you guys want to talk, ask questions, or share your ideas. I would love that. But thank you very much for spending some time with us.